Terminal EVA on Mars.
What's supposed to be a practice for finding underground Martian water quickly turns into a test of the crew's ability to solve the kind of difficult problem that will inevitably crop up on a human mission to Mars.
11 to fix one. We have removed Vladimir's ATV and the crew.
The crew gets the ATV out of the mud quickly, but now the problem is the trailer full of heavy equipment.
Why don't you back it up?
He said to pull it.
Reverse.
Is it possible to drive an ATV back there, put the luggage on and take it? No. Okay.
Can we not try what I was suggesting?
There was some moment of uncertainty, moment of indecision on what to do.
You don't understand, Vladimir. That trailer's not getting out of there unless it's unloaded.
I agree.
The problem with mud also is that there is a time problem there. The longer you stay at the same position in the mud, the deeper you sink.
Not only are they sinking, but their boots are sticking to the permafrost ice that's just 18 inches beneath the surface. After struggling 45 minutes, there's a breakthrough.
We're moving.
The trailer is free, but not Vladimir.
Oh, please, come and help me. Oh, come and help me, please. Oh.
Frustrated by the whole experience, the crew loses patience with their spacesuit helmets and gloves, which would have meant instant death on Mars.
Well, this would be a pretty bad day on Mars.
After spending 1 hour pulling the ATVs and the trailer out of the mud, well, we decided to just abort the expedition and to come back to the hub.
The expedition turns out to be just the sort of group test that astronaut crews will have to face before really going to Mars. And this crew has mixed feelings about its performance.
Whoa. Whoa. Now that was an EVA. That was the epic. That was the pinnacle of all EVAs. Nothing will beat that. We've gone down in history. It was sort of disastrous, mixed in with a small amount of incompetence, but within it there was glory.
Yes. We have discovered mud on Mars.
First thing, I'm very disappointed. Of course, we did not succeed in deploying anything, so we do not have any measurement, and I'm disappointed for that. The second thing, in the dynamic of the group, some of us did not actually put really the hand into the mud and push or pull whenever it was needed. But this is something which I feel should not happen on the field like we were today. I have no data, simply.
So yeah, on Mars, you'd have 455 more days.
Sure.
Today, the Devon Island simulation turns its attention to the enormous crater located right next to the habitat.
So, if you want to orient this as it is on this map, okay, north is this way, towards Charlie. And now our habitat base camp is right here, on Haynes Ridge. That's home. And the crater, you can even see the rough circular outline of it. What makes this place exceptional is that it bears one of the largest impact craters known on our planet, the Houghton Crater. It's a meteorite impact crater that was created 23 million years ago. The boundary of the crater runs around like this. It's 15 miles across. This is the crater, roughly. It is the result of the impact of an object, an asteroid or a comet, we don't know, that was perhaps half a mile across. Impact craters are important on Mars. They are a very common, ubiquitous geologic feature. If you're interested in learning how to explore Mars and at the possibilities of life there, impact craters become a very important target. Not only are they just holes in the ground, but they are also places that have experienced heat and perhaps liquid water for a time. There are shocked gneisses.
Many scientists believe the rocks around Martian craters having been melted and cracked and bathed in water unfrozen by the meteor impact, might be a good place to look for life.
That's where they were originally.
My name's Charles Cookell. I come from the British Antarctic Survey in Cambridge. 1, 2, 3 testing. And I'm a microbiologist. I study microbes in extreme polar environments. So what I also want to do is to break this open and actually carve out some rock from the inside. My personal prejudice is that we will find evidence of past life on Mars. If there was life, it would probably be very, very simple bacteria. Yeah. Maybe the sorts of things that live underground and live off very basic chemicals.
With Martian life in mind, Charles and 3 others prepare to go out into the crater.
1, 2, 3, you read?
On a real Mars mission, astronauts will most likely breathe pure oxygen during their EVAs to compensate for the low pressure of their spacesuits. Such low pressure is needed to keep a suit from ballooning up and stiffening in the thin Martian air. Maintaining the spacecraft itself at low pressure would be convenient, except that the required high oxygen would create a fire hazard. So Mars astronauts will have to transition from high to low pressure and low to high oxygen every time they go outside, just like the crew is simulating here.
Pressurization is now complete. You are go for EVA.
The crew has to spend half an hour depressurizing in the airlock before they can come outside. But at last, they're heading to their destination, a place deep in the crater where they can find rocks that were smashed and beaten by the meteor.
This is fairly rugged terrain, and there's even rougher on Devon Island. On Mars, I'm sure there will be a combination of types of terrains. Probably some terrains that are very smooth. Some, like the Viking landing site, sort of blocky but still manageable. And others that might be just like this. So just from the operational standpoint, coming here is a useful exercise because we get a sense of what we want to be prepared for in the case of Mars.
An hour into their journey, the crew encounters mountains of gray rock, rubble that was seared by the meteor impact, hurled up into the sky, and then rained back down to Earth. As a result of all the trauma, the rocks are now full of cracks and air spaces. Although you can't see any signs of life on the outside, there might be bacteria or other microbes inside. And the same could be true of rocks near Martian meteor craters.
So how much time we've got left?
It's been an hour and 30 minutes since we left the hab.
Out of our backpacks, we still have 3 hours minus half an hour, 2.5 hours. Minus the 30 minutes for contingency, that's just 2 hours left on our backpacks.
Right.
Okay, so we need to head back because if we were to walk back...
Having enough oxygen at all times to walk back to the spacecraft should vehicles get stuck or break down would be standard procedure on a real Mars mission. Back in the habitat, the gray Devon Island rocks are cut open to see what's inside.
When you slice open the rock and you look at it under the microscope, you see the green microbes actually growing within the rock. And they're growing within the rock so they can protect themselves from the ultraviolet radiation and extreme desiccation. It's like a little microenvironment. And it's that sort of existence in an extreme environment that we're interested in terms of trying to look for life on Mars. Should we be breaking rocks open on Mars and looking for life in the same types of locations that we find it here in the Arctic?
Mars simulation, day 11.
Well, we're the next crew, and we're come from far. From Sri Lanka, from Denmark, from France, from Canada, from the US. This looks like nothing before I've seen.
Certainly not Earth. No Earth I've ever seen.
The new crew, commanded again by Robert Zubrin, will spend the next 10 days in the habitat, more than any other group this season. As they settle in, it quickly becomes clear someone else besides Zubrin is a Mars fanatic.
Here you have the Earth and Mars spinning endlessly through space around the Sun, crossing by each other every 2 years and 2 months, like so.
Hi, I'm Charles Frankel. I come from Paris, France, but I also did my studies in the US, and I'm a geologist by training, and I do science writing as well.
Mars is my favorite planet, after the Earth.
Doesn't say Froggy, it says Frankel. That's great. I'm here because of the love of planetary exploration. I grew up as a kid loving the Apollo flights. I met a lot of the men who walked on the moon. I don't think I will ever make it to Mars, but I'm very excited in preparing it for other people.
You're the commander of the EVA, okay? Which means that you should do most of the talking to Ham.
We will ultimately go to Mars. That's a given. The only question is when.
Okay, the door has been sealed, and we're all three standing now at the foot of the ladder.
Mars beckons us for 2 reasons. It's a planet that has as much land exposed as the Earth, so it's Earth number 2 in a way. And it's close enough, really, to colonize. And that's not science fiction. It will be science. It will happen.
This is our first time as a crew in a spacesuit on another planet, or so it seems.
It's a very warm experience. Yeah, very hot in here, very humid. It's not very heavy. You can fairly easily move. Maybe because of the gravity.
And looking over the landscape is actually breathtaking. We know from aerial photography before landing, quote unquote, that we're on the rim of an impact crater, looking into a very wide depression full of interesting rock formations of all different colors, grays and browns and tans. We are attempting to survey the minerals and the rocks all around the hab to have a sense of the mineralogy of the place, since these are our first steps on the surface.
We sampled one of them.
And taking a few samples along the way, which we will analyze back in the hab.
So we've been able to do fun science here. We've been out in the field, we've collected samples, and it's been kind of a game to, of course, figure out what are we looking at.
None of the crew members are experts in Devon Island geology, so they consult often with colleagues back home, a parallel to what might happen on a real Mars mission.
Dioxide.
I think a crew on Mars would have a lot of interrelation with Earth because we might not have all the specialists we want on a crew flying to Mars, so we'd have to rely heavily on support from the Earth. And that interaction is very important.
To test this idea of getting support from Earth, we travel a mile back to NASA Base Camp, where a simple experiment has been organized to see how communication might actually work between a Mars crew and home. Pascal Lee and Charles Coquelle are not in the simulation right now, so they're pretending to be scientists on Earth talking with Mars astronauts by a slow, two-way video conference.
Good afternoon, how are you doing? I guess we can't hear you because you are on Mars and we're 20 minutes or so removed from you. But we have a science traverse plan to send up to you.
So this traverse will be a joint geology and biology traverse. We have some microbiology objectives and some rock collecting objectives. Now, if you go on the objective of the experiment was to simulate some people on Earth putting together an EVA plan and then transmitting that to a crew on Mars and have them perform that EVA based on the information sent to them by the crew on Earth.
The main objective of the traverse we would like you guys to carry out is to reach a distant and massive ejecta block.
It's a rock the size of a house, apparently thrown from the crater when the meteor struck.
Thanks, Matthew. That's the take of the traverse. If you could take us to the habitat.
Drive safe, okay? Thank you, Matthew. We could have sent this message to the crew by radio waves, but we chose to have Matthew Pudlook, this young student who was working with us this summer, carry a tape to the habitat crew with our request. We were simulating this grand time barrier that exists between the Earth and Mars.
The time barrier comes from the distance between Earth and Mars, which varies from 34 to 250 million miles.
Mars is not like the moon from the standpoint that it is much farther away. When you say hello on the Earth, radio signals will carry your hello at the speed of light to the moon in 1.5 seconds. Mars, the shortest one-way light time trip is 4 minutes. when Mars is closest to the Earth. It can go all the way up to 20 minutes, and this is the one-way light-time trip. This will have a profound impact on how we can stay in touch with people on Mars, how we can help the crew on Mars.
Following on from the fact that it's an ejector block, of course we don't know how shocked the block is. But if it was shocked during the impact event, the cracks may provide a habitat for life. What I would like to do is, if there is life in that rock, is to estimate the biomass that is living on the entire ejector block.
Okay guys, this is it. We hope you have a great EVA and tell us all about it. Good luck.
All right, that's good. Listen, the way we're going to do this, we're going to do a 4-person EVA, and Christine will be Capcom. And we're clear the instructions are to proceed as directly as we can to the site of interest. So we're ready to go, and look forward to doing this tomorrow.
The crew heads deep down into the meteor crater, following GPS satellite coordinates sent by Pascal and Charlie.
How close are we to Trinity Lake?
Not sure. We're going to take a reading. So are we right here where these two break off? We have to go almost 2 kilometers that direction. I think that's the rock.
While there wouldn't be a GPS system on Mars, astronauts would have some electronic means of navigating. After an hour-long journey, the crew arrives at their target, and the rock is the size of a small house.
Stand by for GPS coordinates of our primary objective, the large house-sized rock. Over.
What we're going to be doing here is we're going to be measuring the size of this boulder and also sampling pieces, chunks, slivers off it all around, trying to see how much is being eaten by lichen and other forms of microscopic life. There are green stains, vermilion-colored lichen, even mossy material in here, as you can see. So we'll be trying to figure out how many fractures there are, because microbes like to live in those fractures. And then we'll have a pretty good idea of how many kilograms of life are in this rock.
It's not clear that this rock was sent here by the impact. It may have been. We're trying to determine that.
This stuff seems to have been very much molten, almost like a lava, a frothy lava. There was a lot of gas that came out of this, carbon dioxide probably. It's obviously impact related. It is a pudding of fragments held together by a froth of molten rock, so I would tend to believe it was kicked out of the crater by the impact.
Next, the crew is supposed to find out how big the rock is.
Robert currently has the tape measure out.
This rock is 25 feet long. We'll measure the width and the height as well. If we know the size of the rock, we can calculate the mass of the rock, and that would give us an idea of the force that had to eject it to fly it this far, if indeed it was ejected by the impact. Now we're going to try to get some idea of how tall it is. Right here.
Using a simple system of geometry, measuring various triangles and sighting up to the top of the rock by eye, they come up with a good estimate for the height.
That would therefore mean the rock is about 21 feet high.
Based on the size of this and other ejecta blocks, scientists calculate the meteor which smashed into Devon Island must have unleashed a force that was 50,000 times more powerful than the nuclear bomb dropped on Hiroshima.
Other things. Who wants to cook tonight? You just have to think about it. You're basically shopping for a family of 6. But now, on an actual Mars mission, of course, you'd want to stock up for a year and a half.
Here in the habitat, at least while Zubrin has been commander, crew members are taking turns cooking each night. While the ingredients they have to work with mostly come from cans, on a real Mars mission, most things would be dehydrated to save weight. As for why they don't just eat space food, the answer is simple. It's a nice change from rushing around in spacesuits. Perhaps astronauts on Mars will feel the same way.
Why are the forks on this side? Is this a Martian custom?
You know, in America, people hold their forks in the right hand.
Really? The crew comes together best at dinner time. That's when we all can sit down and relax. We're usually pretty beat, especially those who've been out on EVA. But it's a fun moment, and there's a lot of cracking jokes.
The inner planet goes on the inner orbit, the outer planet goes on the outer orbit, and between the two there's an ellipse defining the home and transfer, the minimum energy trajectory between the two worlds.
So we have a good time at dinner, and the food's excellent because we really put our heart into it. We try to outdo the other cooks, and the food, for that reason, has been superb.
So far, so good. Low safety.
After dinner, of course, comes washing dishes. And that means tapping into a resource that will be precious on a Mars mission.
Water. Water is the staff of life. And it's the key issue in a human Mars mission. On Mars, it's the key substance that we're looking for as part of our search for life. It is, in fact, the central issue that will determine whether a mission will occur at all. A human Mars mission will only be possible if we can keep water consumption tightly constrained and recycle the water that we use. So we're going to get a fill soon, so I'll write July 19th. 9 a.m. We do a water refill here about once a day.
Okay, should be coming through in 36.
Our tank has a maximum capacity of 35 gallons. It's coming in.
Okay, we're seeing it now.
Well, we were. Stop. We're not recycling water here as you would on a Mars mission. We don't have the equipment for that.
How are we doing with the water, Robert?
Well, we got a ways to go.
All right.
What we are doing is we're counting the amount of water that we're using, because after propellant, water is by far the largest consumable used on the mission. I have to emphasize that the amount of water a crew uses is the most important logistics variable of a human Mars mission. It determines the mass of the mission, it determines the cost of the mission, and therefore it determines the political possibility of the mission. You use much more water than you use food or oxygen. Not so much to drink. That's comparable to the amount of food that you eat. But to wash with. Wash pans and your hands and your face and clothes and showers. There's no way a Mars mission, even with the best recycling gear, could put up with water use on the scale that people are accustomed to doing it in modern society.
After every activity that involves using water, crew members climb up to the storage tank and measure how much less there is than when they started. The hope is to understand how much water they really need to get by.
Now, measuring the amount of water that we're using determines how much water needs to be either supplied or recycled a day. Additional questions revolve around what kind of recycling system. And in order to understand that, we are doing chemical measurements of the quality of this water and of the quality of the gray water that we drain from the HAB. So, in looking at what you have to do to change that water back into this kind of water, you learn about what kind of recycling system you're going to need. The amount of water tells you the size of the recycling system. The chemistry tells you the kind of recycling system. And on the basis of that, we hope to develop a water recycler that we'll be able to implement here next year.
Okay, thanks, Brett. Over.
It's day 17 in the Mars simulation, and a new crew member arrives with some unusual American military technology.
My name is Lieutenant Colonel John Blitch.
Treat it like American football. And you're running for the end zone.
I'm a program manager for the Tactical Mobile Robotics Program at the Defense Advanced Research Projects Agency.
And remember not to grab the camera as the handle.
The area of portable robotics has a wide range of application. And I think there's a lot of commonality between military applications and this particular endeavor.
On ladder coming down.
It's got a turret on it.
On a human mission to Mars, I think we've got some very daunting tasks. You can't go out every day. There are going to be situations where dust storms are